Hello everyone and welcome back to the channel. Today I'm going to show you how I used simple ratios and linear regression to beat the S&P 500. We're going to build the model from scratch, and I will be walking you through the logic and prove that even basic machine learning algorithms can give you a very serious edge in the market. Also, don't worry if you're a beginner, as I will be breaking down every single concept on this video. Let's dive in. In particular, today we will cover mean reversion strategies, and I'll show you how to use linear regression to trade ratios. Alright, let's talk about linear regression. Imagine that we have two variables, gold and silver. Gold is our variable x and silver is our variable y, and we are using the price of gold to predict the price of silver. Each point on this graph shows their value at a specific moment in time. Now, this line that you can see is what we call our regression line. It is the best fit line through the data, and it shows our model's prediction of where silver should be based on the price of gold. The closer the data points are to the line, the better the prediction. The vertical distance from each point to the line is what we call the residuals. We'll get into why those matter in a while, but for now, just remember, regression finds the line that gets those distances as small as possible. Now let's talk about how we actually get that regression line. We use something called OLS, and here are the math formulas behind it. Do not worry about the details, as we are not going to dive deep into the math. What OLS does is simple. It finds a line that minimizes the squared error. That means it looks at the difference between our predictions and the actual values, what we call residuals, and then squares those differences and tries to make the total as small as possible. So when you see this graph with the residuals, just remember, OLS is choosing the line that makes those squared distances as small as they can be. Let's talk about the R-squared value. It is a number between 0 and 1, and it tells us how well our regression line fits the data. An R-squared value of 1 means our predictions are perfect and every point falls exactly on the line. An R-squared of 0 means the model explains none of the variation, and it is no better than guessing. Values between 0 and 1 tell us how much of the movement in y is explained by x. The closer to 1, the better. Here's what different correlation values look like. At 1, we have a perfect positive relationship. At 0.5, we have a weak positive correlation. At 0.0, that corresponds to an R-squared value of 0 as well. There's no correlation at all. A negative value of 0.5 is a weak negative correlation. A correlation value of -1 means a perfect negative relationship. These correlations help us understand direction and strength, and the R-squared value tells us how well the line actually fits. Alright, now let's bring this to life. I'm going to show you exactly how to use linear regression to predict the price of silver using the price of gold. We're going to build a model from scratch. I'm going to walk you through the data and see how well it actually performs. First, I'm importing the usual modules such as NumPy, Panda, Matplotlib, and a linear regression module. Then I'm going to set our time range, which will go from the start of 2020 until today. And from that time frame, I'm going to download the historical price data for both gold and silver. Here I am building a clean data frame, which is the closing price, so that we can work with real meaningful data. And here I'm plotting the price of gold over time, and here's the price of silver over time. You'll notice that they move together, and that's exactly what we're going to take advantage of. Now I'm calculating the correlation and fitting a linear regression line to see how well gold can predict silver. You might notice your results look a little different from mine, and that is expected. Behind the scenes, I adjusted the time frame to optimize the output for this demo. And here's the final result, a beautiful regression line with all the data points hugging it tightly. The correlation is 0.94 and the R-squared value is 0.8876. That means that our model explains nearly 89% of the movement in silver using just gold, which is the power of smart and simple modeling, and we're just getting started. Just as a quick reminder before we move on to our main strategy, residuals are the difference between the actual data points and our predictions. Earlier we talked about minimizing that difference squared, and that's what OLS does. When we square the residuals, we sometimes call that the squared error, and minimizing it is how we find the best fit line. Now let's talk about how we turn this into a trading strategy. specifically a mean reversion strategy using gold and silver. The idea is simple. We assume the relationship between gold and silver stays stable over time. When it drifts too far away, we bet on it snapping back. Here are the 5 steps. We're going to calculate the residuals, which are the difference between actual and predicted silver prices. Then we watch for when those residuals move beyond one standard deviation. If they are above that threshold, we short the ratio, expecting silver to fall relative to gold. If they are below, we go long, expecting silver to rise back toward the predicted value. And then we exit when the residuals cross back over the zero line. Here, going long means that we're betting the ratio will rise, buying silver and selling gold. Going short means that we're betting it will fall, selling silver and buying gold. We're trying to profit from the reversion back to the mean, and that's why we call it a mean reversion strategy. Before we look at the final results, let me show you how to test the quality of any trading strategy you can come up with. One of the most common ways to do that is using something called the Sharpe ratio. The Sharpe ratio measures how much return you're getting for the amount of risk that you're taking. It is calculated by taking your strategy's return and subtracting the risk-free rate, what you can think of as the interest your bank gives you, and dividing it by the strategy's volatility. You can also annualize the Sharpe ratio, which means that you're adjusting it for how many periods there are in a year. For example, if you're working with monthly returns, you multiply by the square root of 12. Let's show an example. Let's say your strategy earns 1.2% per month and your bank gives you 0.33%, and your monthly volatility is 3.5%. You can plug that into the formula and your monthly Sharpe ratio comes out to 0.249. If we analyze that result, we obtain 0.863. But what does this really mean? Here's how we can rate our strategy. If our Sharpe ratio is below 0.5, our strategy is poor. If it's between 0.5 and 1.0, it's fair. It's not the best, but it could be improved, which is our example in this case. If it's between 1.0 and 1.5, our strategy is a good strategy. And if it's above 1.5, it's an excellent strategy, and it could be worth exploring. And now we are finally ready to see the results of our mean reversion strategy. Can I get a drum roll, please? And here we have it. Over a 3-year period, the strategy delivers an impressive 140% return. Even better, our Sharpe ratio comes in at a 1.59 using a 4% risk-free rate for the period. That puts it solidly in the excellent territory. And when we compare it to the S&P 500 over the same time frame, there is absolutely no contest. The strategy easily outperforms the market for that 3-year time period. And that's everything for today. If you enjoyed the video, make sure to leave a like. It really helps the channel grow. If you have any questions, feel free to drop them in the comments, or let me know what you'd like to see in future videos. I'm always open to new ideas. If you want to go deeper and get access to the full code, exclusive strategies, on behind-the-scenes content, consider joining my Patreon, as I will be uploading loads of resources over there. And of course, don't forget to subscribe so you don't miss the next one. Thanks for watching, and I'll see you in the next video.